So, hello everyone. In this particular video, I'm going to tell you about the problem related to power set. This problem is related to power set, and I will be explaining you what is the objective of this particular problem. So, first, I would like to explain you the objective of this particular problem. Suppose we have got a string S, like this is your string A, B, and C. Suppose like this, we have got a string, and now what we have to do, we have to return all the possible combinations, all the possible, you can call permutations here, all the possible permutations. Well, you are writing here permutations, but to be more clear and with the use of power set, we will be writing here something called as, I will be telling you, we will be writing here something called as subsequences. What? Subsequences. Now, Now, before I proceed further, I would like to tell you one thing about that when you are suppose if you are given in an interview, if you are given this particular question, that you have to find the subsequences, combinations or something kind of that of a given string or a given number, then power set becomes your brute force. Remember this. What it becomes? Power set becomes your brute force approach. And an optimized version is your recursion. So that you will be learning further in coming videos. So, but power set is actually your brute force approach. So, well, if we return to your power set, and if you want to find here the particular, all the subsequences, all the possible subsequences, and remember this, the condition is one more, and that too in a lexico, lexicographically order, lexicographically. This simply means if I write here according to dictionary. Now you must have seen that in a dictionary, if we are starting from the number one, then first it will go and search for all the numbers like it's starting from till it reaches two. Then it will go from one to one till like that, till the time it finally reaches its maximum value. Then finally it goes on one, three, and so on. Like it moves like that. First, it completes all the numbers, like from 1 to 1, 2, then 1, 3, then it comes like that. So, this is the method of lexicographically. But what we need to do, our string is simply A, B, and C. And we have to return what? We have to return all the possible subsequences. Why I erase the word permutations over there? Because basically power set algorithm is a brute force approach used commonly to take out your subsequences. So, like, and what was there a difference between the thing? Like, your subsequence can be a combination, but vice versa can't be true. Remember this line. Your subsequence can be your combination of a particular string. If you just calculate them or if you just want to take out, but your combination vice versa can't be true. Like all subsequences can are combinations, but not vice versa can be true. So this you have to remember here. And how we are going to calculate. So if we are going, suppose if this is our string, suppose if this is our string, then how many permutations will be there? First, we have to calculate this. It can be simply subsequences. Remember, sorry, it should be subsequences. What the word should I be using here? So it will be A, B, C. This will be three. Then the other will be AB. We have to return subsequence. So there is no point of taking out. We are not returning here combination. Remember, so we won't be taking BA here. Then we'll be taking AC. Then we will be taking here BC. Simple. So these are six. One will be your empty set. That is simply your no combination. And what will be the other one? The other will be this whole subsequence itself. So these are three. And in total, you got eight subsequences. So what inference that you can make from the given string? The inference that you can make here is simply the length of the string was n equal to 3 and you got subsequences 8. So what you can say? You simply got 2 to the power and subsequences. Is that so? So now how we will be taking out these subsequences? So basically, if we are having 2 to the power n subsequences, 2 to the power n subsequences, then we will be simply writing down the number of, like we will be writing down, or it won't, we will not be writing down in our actual code, but for our developing the algorithm, we will be writing down the numbers. What we will be doing, we will be writing down the numbers from 0 to n minus 1, as simple as that. And here that will be 0 for n is equal to 8, 0 to the power 2n minus 1. This we will be doing. For 2 to the power n subsequences, we will be firstly, for to develop our algorithm, we will be writing down the numbers in the binary form, remember, everything, because we are dealing here in bit manipulation, so the number should be in binary form, and it should be, the number should be written from 0 to 2 raised to the power n minus 1. And now I will be writing here. Just see. Suppose 0 is equal to your 0, 0, 0, 0. Okay. Or here I will be taking 3 only, that because I will be explaining you through ABC option. Then it comes your 1. So 0, 0, 1. Then comes your 0, 1, 0. Then comes your 0, 1, 1. Then comes your 1, 0, 0. Then comes your 1, 0, 1. And then comes your 1, 1, 0. And lastly, all three become 1. So what inference you can make? Now what you have to do? Your string was A, B, and C. This was your string. And you know the indexing of bit starts like this: 2, 1, and 0. And indexing of string will start like 0, 1, and 2. As simple as that. So now what will happen? Simple. Just say you will try to find out at particular index of the given number. See, at particular index of this particular, all the numbers that you have written from 0 to 7, if you find that at any particular index of those numbers, if you find a particular set bit, remember, mark my words, if at any particular index of the number, if all these numbers you have written from 0 to 7, and then you will find that in every number, if at any of the indexes you find the set bit, then the same index you will put in a variable here. Simple. Like in the first, we are not able to find any of the index which is has having a set bit, so we won't actually check here. So we will simply be returning here an empty set. Then in our one number, we find that at the 0th place, we have got set bit. So at 0 place, what is the index here? It is A. So it comes A. Then it is 1. So this comes B. Then here comes something as 0 and 1. So that is your A, B. And then here comes like simply C. So here comes C. So are you noticing what we have to do? Similarly, we have to go for all, and we will be getting here in total 2 to the power n subsequences. I repeat once again what we have to do. I will repeat from here. Like first, after, like we always know that if we have got a particular string of length n, then we have to find out, and if we have to find out its subsequences using power set algorithm, which is brute force for taking out the subsequences. So what we will be doing here, if we try to write all the subsequences of the particular string on a paper, we will find that we will be getting here 2 to the power n subsequences. And when we have found out that we will be getting 2 to the power n subsequences, then firstly we have to, just for developing the algorithms using the numbers, that is from 0 to 2 to the power n minus 1, we will be comparing the numbers with the each of the numbers with the given string. How? That in each of the number on whichever index, remember what I'm saying, that in each of the number on whichever index the bit is set, that is 1, we will copy that index into the particular, I think you will be taking a null string. So in that particular, we will be copying it, and then we'll simply push back this particular string into a vector that is will be of a string data type. And finally, you will be getting like this. Now, how you are getting? You have written down all these numbers, and now you will check. Like at 0, you don't have any set bit in this, so it will be an empty. Then at zeroth index, you have got a set bit. So you will compare this to the string. And you have found out that in the string at zeroth index, it was A. So you wrote down A. Similarly, on the first index of the given number, you have found 1. So you will be comparing this with the given string. You have found out at 1, it was B. So you have written down bit. In this manner, you will be getting 2 to the power and subsequences. And that is what you are getting here. So I will be telling you the time complexity as well, but straight away we will be going into the code. So here is the code, and I will be explaining you the code how I have written here. So I have created a class, and in order to assess the members of this particular class, I have taken the access specifier as public, and then I have created a function which will return a string, a vector of a string. Simple. There will be a vector which will be of a string data type, that it will contain like string values, and then the function name is power set because I'm doing that problem, and then I have taken a string value as parameter, obviously, and then I've calculated what, this is the method to calculate the length of the string that you all know, and then here I have taken a null string here. Simply, this is the method. This is a string which will store the value. Which value? Like these subsequences it will store. It will store these subsequences, and then we will be pushing back. Oh, let me tell you what is this. This particular vector is the vector which we will be returning. Remember this. It is not the particular will be storing the data temporarily, that is the subsequence temporarily. It is not that. It is the particular vector which will be actually be holding the returned values that we have to return. It will be holding the final values. Okay, got it. This particular vector is the vector which will be holding the final value. So what we have done? We have taken the num from 0, and we have written this. So remember, one left shift n can also be written like I have again be mentioning here. One left shift n is equal to 2 to the power n. This is the method. It is not XOR here, is 2 to the power n. Simple. And as I told you, after you have found out the subsequences, so you know now you have to write the number from 0 to 2 to the power n minus 1, that you have done, and you will be incrementing num every time 1. Then you have taken the null string, I will be mentioning here, which will be storing the subsequence temporarily. Null string to store the subsequence temporarily. This is the fact. And then how you have done? You have to traverse through the whole string. Remember this. You have to traverse how? You have to traverse through the whole string. As simple as that. So you will be comparing, like, this is a particular number 0, and then you will be comparing this to the whole length of the string. And using what? This is the AND operator, and this is your bitwise shift, as normal as that. This is your set operator to find the set bit. You have to locate the set bit, you use using the bitwise AND. And this is the fact, this is the masking kind of thing. You have done what? You have simply added that particular character. If what? You have added this particular character if you have found that at that particular index, at the ith value, it was set bit. adds into the null string, adds into the null string if found set bit. As simple as that. And then using what? After you have like completed that particular sequence, you have pushed back that particular p, that null string that was holding that your subsequence temporarily into the vector. Simple. And using this particular approach again and again, you will find that you have stored all the subsequences, that is 2 to the power and subsequences into this particular vector which you have to return. This was the vector that you were supposed to return. And now, why have we have done sorting? That is very common. So we have done sorting here to put the subsequences in the lexicographically order. To put the subsequence in the lexo, spelling might be wrong, but you will understand that. Lexicographic order. Simple. And then what I have done after I have finished the sorting process, uh, I have what done? I have done what? I have returned the particular vector that I was supposed to return. Like firstly, I have pushed back all the particular null strings that were holding the data structure temporarily. And every time when it has pushed back, it has again gone line to the execution, it has become null because it won't store that particular character again and again. So this is a fact. And then I've returned it, and the main method is as simple. I created the object of the particular class. I have created, I have statically declared the particular string. Then because I am returning a vector which is of string data type. So in order to take that, I have to declare a vector of string that is simply in the main method. And then what? I called the function using the object. I pass this particular string, and then using the iterator concept to print the vector, I have simply print the vector. I hope it's clear. If you want, again, I am explaining it. As after we have found out that the number of subsequences for a length of string of length 2 to the n, or for a string of length n, it will be 2 to the power n. Then what we have to do? You have to take the numbers, compare. You have to compare the numbers from the string. So how you will be doing? From starting from 0 to 2 to the power n minus 1, you will be running a loop in which every number will be compared to the each character of the string. Every number will be compared to each character of the string. How? Like using the bitwise AND, you will find out that index, at particular index, if the value is one of these numbers, that is num, then it will obviously make, because you are masking here with one, so it will obviously make one. And if it's not making, then firstly it will get null set and all. So using the AND operator, if you find the set bit is there, then at that particular index of the string, you will simply copy that character into the null string. And after the null string has got the subsequence, so you will simply push back in the vector that we are supposed to return, and then the line of execution will straight away go and increment num again, and then your null string will become one, so on till the time it hasn't reached, it will reach 2 to the power n minus 1. Then, since we were supposed to get the answer in the lexicographic order, we have simply sorted the vector and then we have simply returned the vector. And here it is as simple as that. So I will be running this code and let's see what we are getting. So let's see. Why is it giving the error? Let me see. Let me see. So what was the error? That was just you have to just rerun the code and you will be getting it. So let's see what we are getting the answer. There was not particular error as such that should hamper the answer. So I did nothing. You just find out I did nothing. And simply I did what? I did here like as simple as that. What I explained you. And then you find out in the output. You got your A, you got your AB, you got your AC, you got your B, you got your BC, you got your C, you got your ABC. And at this particular index, At this particular index, you have got your empty. Don't think that this line is blank, but at this particular index, you have got your empty set. That is like empty subsequence that has got no element. So now you find that you haven't got BA. So remember, you haven't got BA. Simple as that. You haven't got BA, you haven't got CA, you haven't got CB. So what is the problem? These are the your subsequences of the given string. These are not your combinations. But that doesn't mean that these are like not your combinations here. These are combinations, but vice versa can't be said. Like all combinations can't be subsequences, but all subsequences are combinations. Remember this. So, like that, and let's discuss the time complexity and space complexity of this particular question. So, since we are actually iterating it like what? We are iterating it n 2 to the power n times. So, simply, and we are pushing back also the vector as simple as that. So pushback actually takes time complexity of big O of n, and we are running this loop till the time of what? We are simply running this loop for 2 to the power n minus 1 plus 1 times because plus 1 will come because of what? For one time when the condition will become false. So it is like this will run time complexity will simply be if I write here, your time complexity will be big O of 2 to the power 2 to the power n, and pushback requires your time complexity of pushback requires what? Pushback requires your time complexity of big O of n. So this is the case. So this will be your time complexity of this particular structure till this pushback or till this for loop, what you're calling. It will be your n big O of n into 2 to the power n. And sort takes the time complexity n into log. So any day n into log n will take lesser time, but the maximum time that your output will take will simply be your n into 2 to the power n. So your time complexity of this program will become simply, I will be writing here, time complexity of this program is big O of n into 2, 2 to the power n. This space complexity will be the same. That will also be big O of n into 2 to the power n. So this was all about your power sort. This plays a very vital role when you do the program, and even during recursion when you are supposed to mention about the combination and subsequences printing, you are asked about the brute force approach. And this is the brute force approach. That is the parse algorithm. So this is highly important. So that was all about this particular problem. So hopefully you all have understood. Thanks for watching. Do like, share, and subscribe. Thank you everyone for watching.